How to perform peptide mapping of GLP-1 analogs using LC-MS. A GLP-1 analog batch clears every upstream quality check, appearance, potency, purity by HPLC, and then fails comparability at peptide level because a single acylation site wasn't where the sponsor thought it was. That's not a hypothetical scenario. That's a conversation that happens more often than anyone in this industry wants to admit. Hello, I'm Raghuvar Singh Parmar, Scientific Affairs Director at Resolve Mass Laboratories, where we specialize in structural characterization of complex peptides and biosimilars using LC-MS, HRMS, including the molecules that are hardest to map. What is GLP-1 peptide mapping? Peptide mapping at its core is a structural audit. It confirms that amino acid sequence is exactly what it is supposed to be, that the lipid modifications are at the right locations, and that the degradation products, the ones that might not appear anywhere else, are fully accounted for. For GLP-1 analogs, this isn't a checkbox exercise, it's the analytical foundation that regulatory reviewers will scrutinize when you file. Without this, you are asking an agency to accept a structural claim you haven't fully demonstrated. Why GLP-1 analogs are challenging? Here is where GLP-1 analogs diverge from standard therapeutic peptides. The fatty acid chains that extend their half-life, the same chains that make them therapeutically effective, create real problems in the analytical lab. Hydrophobic fragments adhered to surfaces and column hardware. Modified regions resist standard enzymatic digestion. Signal intensity becomes inconsistent, and that inconsistency is hard to diagnose if you haven't mapped a molecule like this before. A team experienced only in the conventional peptides will often misread a recovery problem as a sequence problem. That distinction matters enormously when you are trying to build a credible data package for a submission. Step number 1 is sample preparation. Before the molecule ever reaches the column, it has to be unfolded correctly. Urea or guanidine hydrochloride for denaturation, DTT to reduce disulfide bonds, alkylation to stabilize cysteines. These aren't novel steps, but concentrations and timing matter more with lipidated peptides than with most other biologics. Incomplete denaturation doesn't always produce a failed run. Sometimes it produces a result that looks acceptable and is wrong. That's the more dangerous outcome. Step number 2 is multi-enzyme digestion. No single enzyme achieves full sequence coverage on a GLP-1 analog, and this is where many mapping strategies fall short before they even reach the instrument. Trypsin handles the standard backbone regions reliably. Glucose picks up the acidic. C-terminally modified segments are trypsin misses. Chymotrypsin targets the hydrophobic fragments, the ones most likely to be lost without the right enzymatic approach. The overlapping peptides generated by this parallel strategy are what give you genuine confidence in your coverage map. If you're working from a single enzyme digest, you have gaps. In regulatory filing, gaps become formal questions. We worked with a sponsor preparing a biosimilar comparability package who had strong trypsin coverage, about 85%, and believed the characterization was complete. When we ran glucose and chymotrypsin digest in parallel, we identified a missed acylation variant at a fragment that trypsin simply doesn't expose well. It wasn't a safety finding, but it was a comparability issue, and it would have surfaced during agency review rather than in our lab. 3 weeks of additional analytical work protected what could have become a 6-month filing delay. Step number 3 is chromatographic separation. Chromatography is where many GLP-1 mapping workflow quietly fail. C18 columns, the default in most peptide labs, are not well suited for lipidated fragments sometimes. C4 stationary phases reduces carryover and improve recovery for most hydrophobic species. Elevated column temperatures, typically in the 50 to 60 degree temperature range, significantly improve peak safe for the difficult fragments. Gradient design matters more than people expect. The difference between the gradient that resolves two closely related impurities and one that coelutes them is often difference between a clean data package and FDA query asking you to repeat the entire separation. Step number 4 is high resolution mass spectrometry. The Orbitrap platform delivers the mass accuracy required sub 3 ppm on intact fragments to confidently assign modifications. HCD fragmentation is the workhorse for backbone sequencing. ETT becomes essential when you are working with fragments carrying labile modifications that HCD would destroy before detection. Oxidation and deamidation are the modifications most likely to appear in stressed or aged samples, and in high resolution MS is the only way to quantify them with the specificity that regulators expect. Impurity and acylation mapping. For biosimilar programs specifically, the ability to identify exact modification sites and measure mass shifts below 3 ppm is what separates a characterization package that withstands scrutiny from one that generates a deficiency list. Impurity mapping and acylation confirmation are not supplementary data, they are the evidentiary core of a comparability argument. What this workflow ultimately gives you is the ability to demonstrate, not just assert, that your molecule is structurally what it is supposed to be, full sequence coverage through multi-enzyme digestion, chromatographic conditions purpose built for hydrophobic fragments, mass spectrometry sensitive enough to detect modification a less capable platform would miss entirely. Getting all three right on a molecule this analytically demanding requires a workflow that was designed for it. GLP-1 peptide mapping isn't technically difficult if you have done it enough times to understand the failure modes. The challenge is that most labs haven't done it. If you are approaching an IND or biosimilar filing or a comparability study and you are not certain your mapping strategy is fit for purpose, that conversation is better held now than after a submission. We are always willing to look at a specific molecule and tell you honestly what it requires. Thank you so much for watching this session, and I hope it helps you. Goodbye for now. See you in the next one.